All right, in this video I'm going to be talking to you about problem solving. And of course, a lot of people hear those words and they're like, oh no, we're going to be solving word problems. And that's true here. But I just want to say, this skill of problem solving is actually an important skill. Of course, using equations to solve problems is not necessarily like what you will do in your day-to-day walk, but the ability to be a good problem solver is important. And really what we're doing is the foundation for what we call modeling, where you basically use algebra and equations or expressions to model real life things that go on in the real world. And in fact, like in a calculus course, there's a lot of really great applications where you do some modeling and you can use that to understand certain things better and to model certain real world situations. So we're really just getting a very basic start in doing that. And we're going to focus on just a few problems here, but we're going to try to do them very well. Basically, you'll see two different types of word problems, and then when you're doing your homework, you'll need to do problems similar to those, and then there's going to be a couple that are a little bit different. And I'm hoping that you can take what we do with the first couple of examples and take those that approach and solve some problems that are a little bit different. That's kind of the ultimate goal. So in this process, the first thing that's important is knowing how to translate expressions and how to use variables to represent unknown quantities. So here it says write an algebraic expression for each of the following. So on number 1, it says if n is the smaller of two consecutive integers, express the larger integer in terms of n. So two consecutive integers. So certainly you need to know what consecutive means and also what an integer is. And so our integers, that's these guys, -3, -2, -1, all the way up to 3. Basically, the integers are the counting numbers plus 0, and then the negatives of those numbers. And so consecutive means they follow one another. And so if we say n is the smaller, how would we express the next one? Well, going from 2 to 3, you're going up by 1, right? And so if your first integer is n, we don't know what it is, but the next consecutive integer would be n plus 1. All right, so I would encourage you to go ahead and do 2, 3, and 4, and then watch the video. Let's see what you can do. All right, so on number 2, the first thing I would encourage you to do is draw a rectangle, since this deals with the rectangle. And we normally let the width be the shorter length. That's kind of a traditional approach. Now, it really doesn't matter as long as you're consistent as you're labeling things, but we're going to generally let the width be the shorter side. Now, notice here it says the length is 5 less than twice the width. So this is actually just a phrase that we can translate. So I'm going to use L for length. We use equals, is or equals, 5 less than twice the width. Now sometimes people will write 5 minus whatever here, and that order is going to be incorrect. In fact, be careful with the words less than. For example, if I said, what is 5 less than 100? Wouldn't you start with the 100 and subtract off 5? 95 is 5 less than 100. And so we're going to do the same kind of thing here. We want 5 less than twice the width. So twice the width is 2w. And if I want 5 less than that, I need to subtract off 5. And so our length is 2w minus 5. We were asked to express that in terms of w, or that means using w. And so 2w minus 5 is our length in terms of w. All right, on number 3, it says if S is the measure of one side of a square, write an expression to represent the perimeter of the square. Well, here's my square. I know a square has 4 equal sides. And if one side is S, that means they're all S because they're all the same size. Now remember, perimeter is just the distance around the outside of the figure. So that would be s plus s plus s plus s, which is 4s. We're just adding ones here. All right, so 4s would be an expression that you could use to represent the perimeter here. All right, number 4. Janet is getting a 3.5% raise. Go Janet. If she makes X dollars monthly before any deductions, that means no taxes, no insurance, none of those things, write an algebraic expression for her new monthly salary. Okay, so X is her current monthly salary. That's what she's currently making. So her salary plus the raise, that's going to be her new salary, which is what we need an expression for. Well, X is her salary. Now here's where you have to be careful. How do you express the raise? Well, isn't it 3% or 3.5% of her salary? You know, with percents, it's always a percent of some number. You know, like if you're talking about a tax, or in this case, you're talking about a raise. And so normally what we want to do is write the percent as a decimal. So remember, if you have 3.5%, you move the decimal 2 places to the left and drop the percent symbol. And so it's going to be 0.035 times x. It's 3.5% of her current salary. That's the raise. You need the x there. And so that's going to be her new salary. Now notice these are like terms. And so we can combine these terms together and we get 1.035x. That's an expression that represents her new monthly salary. Now, one of the things I just wanted to mention here is if you think about what this means, 1.035, 1x is her whole salary, current salary. The 0.035 represents the raise. So really what we're saying here is this value is 103.5% of the original amount. And so that's another way to think of that. All right, let's go ahead and move on and look at our strategy for solving word problems. Okay, so my first question to you is, how do you become a good problem solver? Now I know some of you are like, man, I'm just terrible. And maybe you know some people, they're like, man, they're just it seems to come so natural to them. The honest truth is I know there's certainly certain people that seem to be really good at problem solving. But, you know, a lot of those people are good problem solvers because they've been working at it for a long time. And so the bottom line is, if you want to become a good problem solver, it is something that you can get better at, even if you don't think of yourself as a natural problem solver. In fact, what do you need? Practice, practice, and practice. You know, and I think part of the problem is, you know, sometimes when we're young, I remember, I even remember substituting for, like, you know, grades 2, 2nd, 3rd, 4th grade, those, or even younger, I think. And students at those ages are so excited about learning, and you know, it's just they get excited so easily about things, and they want to learn. And I think over time, a lot of kids lose that love of learning and that desire to learn. And I think sometimes when it comes to problem solving, we've had some bad experiences where we were just embarrassed, or you know, sometimes it's just really frustrating, and it really makes you feel not so smart when you can't figure something out, especially if the guy next to you is like, oh, this is easy. But anyway, all to say, you know, some of us, we have some baggage in the past when it comes to problem solving. But again, if you want to get better, number one, you got to be willing to try, and you got to be willing to practice, practice, and practice. And in the beginning, you're like a copycat. I'm going to show you how to solve some problems, and you're going to copy that model, and you're going to do some. But what you want to be doing is trying to make sense of things and you want to keep working at it and trying new types of problems. And by putting in that effort, you're going to become better at solving problems. So for me, I think if you want to be a good problem solver, you've got to be brave. You've got to be willing to go out there and try to give it your best shot. And a lot of times, you just got to be willing to try something. Start writing down what you know, and then just try something. Play with it a little bit. Maybe think about it for a little bit and then come back to it. I mean, you don't want to spend too much time on one problem, but the bottom line is, I've literally had some students that it was almost impossible to get them to even put much effort into word problems. And you're just never going to get any better at it if that's your approach. Especially if you're going to be going on to calculus and some higher level math courses, you got to be willing to jump in, and through practice you're going to get better. And and I don't know about you, but when you put yourself out there and you work at it and you get the answer right and you're like, yes, I did it. That's encouraging, and you can build on that. So anyway, enough preaching about problem solving. Let me just run through this real quick. Number 1, it says read the problem for understanding and strategize. And I'll tell you honestly, I think some students are a little bit, either they're just in too much of a hurry, or there's that lazy word. They're too lazy to really spend enough time on a problem to make sure they understand it before they just jump in and start trying to do some things to try to solve it. So you want to read and see what facts you know, what you're being asked to find. Maybe there's a formula or that may apply to the problem. Maybe a picture or a chart might help. Write some things down and see where it goes. With experience, you get better at that kind of thing. All right, so number 1, you got to understand the problem first. And at some point, you start strategizing. Step 2, you're going to name the unknown. So you're looking for some value. Often that's the case. And so you're going to call that x or some other number. And if there's any other numbers you need to find, you're going to use that same variable x, or whatever you choose, for those other variables as well. All right, so we named the unknown, and then we're going to write an equation that fits the problem or models the problem. You solve the equation, and then you're going to check your answer and make sure you've answered the problem completely. Sometimes students get a number, bam, they stop. Just make sure that you've answered the question. And the other thing is, if you can, it always is a good idea to check your answer. And if you get in the habit of doing that and you're getting right answers when you check, you're going to have a lot more confidence when you're taking a test and when you have to do a problem like that. So there's some common errors here, such as misreading the problem, copying something wrong, using the incorrect equation. The equation has to be right, making some kind of a computational error, or some basic error in reasoning. And sometimes you'll look at it and go, oh shoot, that's not right, and you fix it. I'll tell you, I've literally had students come to me almost in tears, and they're like, Mr. Smith, I've tried this 5 times and it keeps coming out wrong and I can't get the right answer. And I look at it and I'm like, oh shoot, you copied it down wrong. So that's kind of an important thing. Make sure you copied the problem down correctly. All right, let's go ahead and get started on solving these problems here. So it says, so first of all, write an equation that fits the given problem, then use the equation to solve the problem. So on number 5 here, it says the length of a college soccer field is 45 yards more than the width. If the perimeter of the field is 390 yards, find the length and width of the soccer field. Well, let's see, we're dealing with the soccer field, so it'd be a good idea to maybe have a picture. Remember, we like to call the shorter side the width. Now notice here it says that the length is 45 yards more than the width. So the length is, or equals, how do I write 45 more than the width? Well, that would be W plus 45. and so that's my length. Notice I have two lengths and two widths, and so really I could just add these up, W plus 45 plus another W plus another W plus 45. Remember, perimeter, we're just adding the four outside lengths here, and that's equal to 390. Now we could solve that equation, but I want to show you another way you could do this, and most students seem to prefer this. We have a formula for perimeter for a rectangle. It's 2 times the width plus 2 times the length. You can see we have two lengths and we have two widths. So that's where that comes from. Or you can even see it right here. We have two widths and two lengths. All right, so here I would just plug in the numbers. The perimeter is 390 equals 2W, or 2 times the width. We called the width W, plus 2 times the length. Well, we said the length was W plus 45. And so you can see this equation is equal or equivalent to the one we were just looking at. Let's go ahead and solve this. So first I'm going to want to simplify everything. So 390 is equal to 2W. I just distributed here, so 2W plus 90 there. So we have these 2W terms we can combine together. We'll get 390 is equal to 4W plus 90. So to get W by itself, I'll subtract 90 on both sides. You get 300 is equal to 4W. And we'll divide by 4. And you get 75. So our width is 75 yards. And to find the length, we just need to plug in 75 for W here. And we get 75 plus 45, which is 120, and so our length is 120 yards. And it wouldn't be hard to check this at all. We know that the perimeter is 2 times the width plus 2 times the length. So we have 360 equals 2 times 75 plus 2 times 120. And if you check that, you'll see that it is true. Oh, I'm getting ahead of myself here. All right, so on number 6, it's really the same problem with just different numbers, a little different situation. So I would encourage you to go ahead and try number 6 and then watch the video. All right, so let's see how you did. So there's my rectangle, or my piece of paper, right? Notice it says, be sure to show all the work, even if you already know the answer here. So we're talking about a standard piece of paper, the length and the width. So it says so we're going to call the width the shorter side, and it says it's 2.5 inches longer than the width. The length is 2.5 inches longer than the width. So it's really the width plus 2.5. And so let's go ahead and write down our formula for perimeter. And so we have, let's see, 39 is our perimeter, is equal to 2 times the width, which we called W, plus 2 times the length, which we said was W plus 2.5. So let's go ahead and simplify. We're going to want to distribute here. And so we get 39 is equal to 2W plus 2W plus 2 times 2.5 is 5. So 2W and 2W, that's going to be 4W. And then don't forget about the plus 5. So notice we have a two-step equation. We'll subtract 5 on both sides. And then we need to divide by 4. And we get 8.5. And so the width is 8.5, and the length is going to be 8.5 plus 2.5. Remember, we said the width or the length was W plus 2.5, and so we do get 11 here. So it's 8.5 inches wide and 11 inches long. All right, let's move on to number 7. So Michael receives a 6% raise, bringing his gross annual salary to $45,050. What was his gross annual salary before the raise? All right, so that's going to be my X. It'll be his annual gross salary. And that was what it was before the raise. All right, so let's go ahead and write an equation here. But first, let's think of it in terms of the concept. So the salary, his original salary plus the raise is going to equal the new salary. So his original salary was X. How would we write his raise? It's 6%. Well, 6% of what? 6% of his salary. And so it's 0.06 times X. That's how you would represent 6% of his original salary. See, when you talk about 6% raise, it's 6% of what? 6% of his original salary. All right, so that's equal to $45,050. And these are like terms, so we can add 1 and 0.06. We get 1.06x here is equal to 45,050. And to get x by itself, I have 1.06 times x. I'm going to need to divide. And so these cancel. We're left with x is equal to 42,500. It wouldn't be hard to check this. It's going to be 42,500, my original salary, plus 6% of that, and that should equal 45,050. And if you plug that left side into your calculator, you'll see that it does check. All right, so I encourage you to try number 8. It's a little different, but very similar. All right, so let's see how you did. So the cost of a reclining chair has been reduced by 25% to a sales price of $573.75. What was the original price? So X is the original price. And if you take the original price and you subtract your discount, that's going to give you your sales price, or the discounted price. All right, so the original price was X, and we're going to subtract 25%. Well, if you just write minus 0.25, you're subtracting 25 cents. It's 25% of something. What is that? Well, the original price. So minus 25% of the original price, which we called X, and that's equal to the sales price, which we said was $573.75. So notice again, these are like terms. We have 1x minus 0.25x, and when you subtract there, you get 0.75x. On the other side, we have 573.75. Now at this point, it makes some sense to just stop for a second and think about this. This makes sense. If you're going to get a discount of 25% off, doesn't that mean you're going to pay 75% of the price? And that's what this is saying here. We're paying 75% of the original price. So just another way to think of it. So if we divide by 0.75 on both sides, we're going to get x is equal to $765. So that was a nice discount. If you want to check it, we want to see that 765 minus 25% of 765 is equal to 573.75. And you can verify that that is true. All right, that's it for this video.